Hey everyone! Today we're diving into the toolbox for one of the most popular databases out there, MySQL. We're going to skip the high-level theory and get right into the practical stuff, the specific syntax, the little quirks, and the best practices you'll actually use. So let's get our hands dirty and start building.
All right, first things first, let's get on the same page. When I say database, I want you to completely forget about spreadsheets. Instead, picture a digital workshop. And inside this workshop, all our information is stored in these really smart, specialized containers that can all connect to each other. This whole workshop idea, it's going to be our guide for everything we talk about today.
So you can't have a workshop without a plan, right? Before we can store anything, we've got to design our containers. In the world of MySQL, that means we're basically drafting blueprints for our tables, using a command called createTable.
Now, this is where you really start to see the unique flavor of MySQL. See that keyword auto_increment? That's a special MySQL trick for automatically giving every single item you add its own unique ID number. You don't have to lift a finger. Then there's varchar. With MySQL, you absolutely have to tell it the max length, like 50 characters here. It's like telling it exactly how big of a label to print. And timestamp is my personal favorite shortcut. You can set it up to automatically stamp the exact time an item was created. Super handy.
Okay, so for our little workshop project today, we're going to build a simple database for a school. We'll need a container for our students, obviously, and another one for all the courses. And then we'll build a really important third one, enrollments. That's basically the bridge that connects the students to the courses they're taking.
So our containers are designed and built. It's time to actually put stuff inside them and, manage the inventory. We do this with 3 really fundamental commands.
Just think of it like the basic life cycle of anything in the workshop. Insert is how you put new items into a container. Pretty straightforward. Update is what you use when you need to change something that's already in there, maybe fix a typo. And delete, well, that's for taking stuff out.
Okay, now lean in for this one, because this is probably the most important rule of the entire workshop. If you use update or delete without a where clause to tell it exactly which item you're talking about, it's going to assume you mean every single thing in the container. Trust me, it's the kind of mistake you only make once.
So what if you actually want to get rid of everything in a container? You've got 2 tools for the job. You can delete everything, which goes through and removes items one by one. Or you can use truncate. Truncate is like hitting the big red button. It's way faster because it just drops the whole thing and makes a new empty one. And the really critical difference is that truncate also resets that auto-increment counter back to 1.
All right, our workshop is all stocked up. Now for the thing you'll do most often, finding stuff. But we need to do it carefully, with precision, so we grab exactly what we need without making a huge mess.
So let's think about this for a second. How do we look inside one of these containers to see what's in there, without just, tipping the whole thing over and dumping all the contents out on the floor? Because in a big, busy workshop, that would be a total nightmare.
And this right here shows the 2 approaches perfectly. On the left, you've got the scalpel. Select first name, major. You're asking for exactly the information you need and nothing else. And on the right, you've got the crowbar. Select star, which just means give me everything. Now, the crowbar is fine for a quick peek while you're building things, but in a real-world system with millions of items, it is an absolute performance killer. You got to use the scalpel.
And to make that scalpel even more precise, you can add a couple more tools. You use where to filter down to just the items you want, like where major equals IT. And once you have your results, you can use order by to sort them however you like, maybe alphabetically by last name. Okay, this is where the real magic happens. Remember how I said our containers were interconnected? This is how we leverage that. This is the whole point of a relational database, and the tool we use is called a join. Let's start with the most common one, the inner join. It does exactly what it sounds like. It looks at 2 containers and finds only the items that have a perfect match in both. It's the overlap, the intersection, where the data lines up perfectly. Just look at this example. We have our students container and our courses container. When we do an inner join between them, the result only shows us the students who are actually enrolled in a course. If a student isn't taking any classes yet, they're not in the result. It's only the matches.
But what if we want the full story? What if we want to see the students who aren't enrolled, or maybe find courses that nobody has signed up for? Well, this brings us to another one of those MySQL-specific quirks. It doesn't actually have a command called full outer join, but don't worry, we can build it ourselves.
And here's the recipe. It's a clever 3-step process.
First, we do a left join, which gets us all the students, plus any course matches they might have. Then we do a right join, which gets us all the courses, plus any students enrolled in them. And finally, we use a command called union to just smoosh those two lists together into one complete picture.
And check out how powerful this is when you compare them side by side. The inner join on the left, it just shows us John and Sarah because they're enrolled. But our simulated full outer join on the right, it shows us the entire story. We see John and Sarah, plus we see any students who aren't taking courses, and any courses that don't have students. It is an amazing way to find gaps in your data.
Okay, we know how to store data and connect it. Let's wrap up with two final really important ideas: how to summarize our data to get quick insights, and how to make our whole workshop run faster.
So instead of looking at every single enrollment record one by one, we can ask the database to do the math for us. This is called aggregation. Here, we're saying count the number of students and then group them by their course name. And boom, we get a nice clean summary. 1 student in database design, 2 in networking, so much easier to read.
And what about making things faster? For that, we use something called an index. The absolute best way to think about it is like an old-school card catalog in a library. Yeah, creating the index takes a bit of time up front, and adding a new book means adding a new card. But when you need to find something, it is unbelievably faster than wandering up and down every single aisle. That's exactly what an index does.
We have covered a ton of ground, so let's just boil it all down to the absolute golden rules for building a solid, efficient, and reliable MySQL workshop.
Here they are, the big 3. Rule number 1, use foreign keys. This is how you officially tell the database how your containers are linked, which protects your data. Rule 2, you should always create an index on those foreign key columns. This is what makes your joins super fast. And finally, rule number 3, none of this really works right without the proper foundation. Just stick with the InnoDB engine. It's the default in MySQL for a very good reason. It's built for this stuff.
And there you have it. We've gone from a blank slate to a fully functioning digital workshop that can store, manage, and connect data with both speed and precision. So the only real question left is, now that you have the blueprints, what are you going to build first? Thanks for watching.